When you see something like this, remember, this is, when you see these arc signs and stuff, remember, this is telling me that there's some angle, and that angle has a sine of 24 over 25. If you kind of think that way, and I'm going to even write it that way because I think that would help, it kind of gets you going. That's all that arc sine means, is I'm looking for the angle that has that sine. What do I know about sine? If you notice, the directions tell you to find the exact value of the expression. You can use a graphing utility to verify your result. Hint, to make a sketch of a right triangle. Okay, and again, that's what I was going to tell y'all to do. Notice they're trying to give you some hints in there. Here's my angle. If I know the sine value, what is the sine as far as SOHCAHTOA goes? What are the sides that we want here? Yeah, opposite over hypotenuse. If you'll just label everything, because guys, I can't do it unless I label it. So some of you are smart enough that you can. I'm not. Okay. So I have to label it. So I go, okay, the opposite side of this angle, whatever it is 24, and the hypotenuse is 25. Do y'all remember that there's a triple that has those sides in it? It's a weird one, but yeah, it's 7, 24, 25. So the side, you had to actually fill that in. I'll put it in red to show that we actually came up with that. We could have done the Pythagorean theorem, but that's one of those triples. Triples are great to know. They're trying to actually take advantage of some of those in here so that you don't have to do so much math to get the sides. So I've got the angle, I've got the triangle drawn there. I'm done with the inner part. I've got the angle, and I know the triangle that it's in, and what this wants me to do is find the cosine of that angle now. This part just helped me draw the triangle. Now, basically, what's the cosine of that angle there? Wouldn't it be adjacent over hypotenuse? And if you still need to write it down, do that. Adjacent over hypotenuse. I'll just put that step in there, because that's what we're thinking. What is the adjacent side? And the hypotenuse is 25. 7 over 25 is your answer there. Okay, so one of the things that's going to help us, do y'all remember that over on, what was the page number, 320, I think it was, the 322. On page 322, we saw that if you're going to talk about the arctangent specifically, its domain was negative infinity to infinity, but its range was negative pi halves to pi halves. So I'm going to be looking in the unit circle from negative pi halves to pi halves. Negative pi halves is down here. Pi halves is here. I'm only looking for angles that fall in here and here, okay? Unless they tell us otherwise. We could actually find several things that would have this specific secant value, but we're just going to focus in here because of this arctan here. Now, if I'm going to, they remember they gave me a hint to draw a triangle. And I know I'm talking about an angle. If I wanted to rewrite this and think about it, I could say I'm looking for the angle, and the tangent of that angle is negative 3/5. Okay? Let me fill out the right triangle. That's the best way to do these, is draw the triangle and fill it out. Now, tangent is what, according to SOHCAHTOA? Isn't it opposite over adjacent, right? TOA. Okay, so the opposite side is negative 3, and the adjacent side is 5. Now, really, if I wanted to look at this would be like 5, negative 3. Really, that triangle, if I drew it on the unit circle, would be like down here, okay? And I know that tangent only has this domain over here. They're only asking me, if I'm really just strictly looking at the values that would actually fall in the real arctangent, which is, again, I peeked and looked at page 322 to remember that. I'm only going to be looking in these two quadrants here. Let me label them, though. All students take calculus. Down in that quadrant, the cosine is negative, and the sine, so the cosine's positive, so tangent and sine would be negative. I can kind of keep that in mind as I work here. What is this side over here going to be? Is this a 3, 4, 5? No, unfortunately, right? We wish it were, because that would sure make it easy. We wouldn't have to do the Pythagorean theorem. But if we call that side C, we could do the Pythagorean theorem. Even though my triangle really is oriented differently, I can just still use the thing I drew to, kind of work with. Negative 3 squared plus 5 squared is C squared. So that's 9 plus 25 is C squared, and that what, 34? So C would be the square root of 34. So let me write that in up here, because now I use this inner piece of information here, and I can tell you now anything about that triangle you want to ask, any trig function now, right? Okay, they want to know what the secant of that angle is. They're telling me its arctangent is -3/5, now find the secant of that angle. It's basically what's going on here. Well, secant, if I'm trying to look at my triangle to figure it out, secant is the cosine flipped, isn't it? Aren't they reciprocal functions? So if I could find the cosine, let's find the cosine of the angle, and then we'll just flip it. What would be the cosine? Adjacent over hypotenuse. It would be 5 over square root of 34, right? Okay. So if I flip it, I would have my secant. What's my secant? Square root of 34 over 5. Should this be positive or negative? Look at your all students take calculus. In that last quadrant, cosine's positive, so its reciprocal would be positive, so I know I got the right sign on it. You should always check your sign that way, just because, especially with these problems, it gets a little, it can get a little confusing. Okay, so here you might think, I don't know very much, how am I going to fill out a right triangle? They said cotangent of arctangent of x. Well, first of all, aren't these two things opposite? So wouldn't it, if I wanted to find the cotangent of the arctangent of x, since those are inverse kinds of, or are they inverse kinds of things? If I had tangent of arctangent x, it would be an inverse. But it's so easy to get that idea of inverse functions mixed up with reciprocal functions. Cotangent and arctangent are reciprocals. If I had tangent of arctangent of x, my answer would be x. Since it's cotangent of arctangent of x, I have a feeling the answer is going to be 1 over x, because you just flip it. But let's verify it. We can figure out a whole lot more than we think we can here. If tangent of x, remember I can rewrite this, or I can think of it this way, so I'm going to think of it this way. It is opposite over adjacent. That's what tangent is, right? So tangent of x is opposite, tangent is opposite over adjacent. I meant to write that to the side. I meant to write tangent of some angle. Let me just write another line, because that's going to get way too sloppy. So here's what I could think. I'm thinking tangent of some angle is x. And I know that x is opposite over adjacent. I kind of didn't write it the way I intended to. So I could put that x over 1, and I could say, okay, let me put my angle right here, because I don't know where it is, so I'll just put it somewhere in the triangle. The opposite side is x, and the adjacent side is 1. Could I find the hypotenuse to that? It wouldn't look pretty, but I could do it. Let's do it. If I want to find the hypotenuse, I could say, I can use the Pythagorean theorem. The hypotenuse squared is equal to the two legs squared added together. So it's going to be x squared plus 1 squared is c squared. So I can't combine those terms. I can't write that any differently. I could square root both sides. So c, square root of c squared would be c, is the square root of x squared. Well, 1 squared is just 1, isn't it? So I could write this here. Now, I really didn't need the hypotenuse here to answer this question. I just wanted to show you what you would do, because on the other ones you're going to need to do this probably. If I write that whole right triangle and I fill out all the sides of it, I could answer any question they asked. Now, I really didn't need to find the hypotenuse here, because what did they want to know? They wanted to know what's the cotangent of that angle that we're talking about now. Well, the cotangent, if the tangent is opposite over adjacent, wouldn't the cotangent be adjacent over opposite? So what would the ratio be? Yeah, 1 over x. Which will kind of, I said I think it's going to be that, but let's just make sure. And again, you could have figured it out reasoning, because you could have said, well, if tangent is x, arctangent is x, then tangent of arctangent x would have been x, but the cotangent really would just be flip that fraction, so it would have been 1 over x. You could have reasoned that out that way without having to do as much work, but I wanted to prove to you that that reasoning actually was okay. We could actually think that way by actually working it all out like this. But I know they've given me a hint, and pretty much almost on anything we do in this chapter, if we draw a right triangle, it's not going to hurt us. It'll probably only help us. So that's kind of just a good rule of thumb here when you're dealing with trig, because it's all about right triangles. So if I want to think about it, here's what they're telling me. I want the sine of some angle. I don't know what the angle is, but I do know something about the angle. I know that the arc cosine means that the cosine of that angle is x plus 2. Do I know anything from SOHCAHTOA about cosine? What are the sides of a triangle for cosine? It's, yeah, adjacent over hypotenuse. So maybe write that down if that, to me, just writing stuff down helps me see what to do. Oh, I have a fraction. I'm supposed to have a fraction, and I don't. I can always create one by sticking something over 1. There's another side, right? It didn't look like it was there, but I can always write it and use that if it's not there. So I know if I write my angle right here, my adjacent side is x plus 2, and my hypotenuse is 1. All I'm doing is using that information to fill out something. Oh, that looks fun, doesn't it? Okay, we're missing a side. It's a leg. Let me just call it B or something, just because usually we call our legs A and B. I'll just call that one B. If you remember the Pythagorean theorem, you could write a squared plus b squared is c squared. But if you're missing a leg, do you remember that you could just alter the formula to say it's the hypotenuse squared minus the other leg squared, which, if you don't remember, the books sometimes give you that as a formula, but you could always just take the regular Pythagorean theorem and subtract a squared from both sides, and you could end up with this. Sometimes I like messing with the formula before I put the numbers in. You could put the numbers in and then solve for whatever you needed here. But the b squared would be the hypotenuse squared, 1 squared, minus a squared is x plus 2 squared. Okay. Well, we probably don't want to leave that way. It probably will simplify a little bit. So do you remember that when you have x plus 2 squared, that's 2 copies of x plus 2? Everybody wants it to be x squared plus 4, but it almost is, but not quite. I don't know if y'all remember that when you multiply that out, it would be 1 minus, that would be x squared. And then remember the middle term comes from these, multiplying these things together. You got 2x, you got 2 more x, that's 4x. And then 2 times 2 is 4. You could multiply it out, just distribute if you don't see that shorter way of doing it. But really your middle term always comes from these kind of like smiley faces underneath it. Multiply the two things and then add them together. So let me come over here because I'm out of room. 1, it'd be 1 minus x squared, because I got to distribute that subtraction sign, minus 4x, and then minus 4. So b squared, actually 1 minus 4 is negative 3, so it's going to be negative x squared minus 4x minus 3. That's what the b side is over here. Negative x squared minus 4x minus 3. Kind of hard to fill that in with this big old marker, but that's what this side is right here, basically.
Would it be square or?
Oh, square root. Yeah, sorry. Thank you. Forgot to square root. Thank you. Very good catch, Ben. Yeah, square root both sides. Thank you. Now, I did need that side. It looks ugly, but I needed it because isn't the sine of this angle, I've used all this, I've drawn my triangle, that's all I'm going to do with it. I'm just using it to figure out the right triangle. Now I want the sine of that angle in that right triangle. It's going to be the opposite over the hypotenuse. So the opposite is that ugly negative x squared minus 4x minus 3 over the hypotenuse is 1. So I could have just said, oh, the sine is. Here's another way the key might write it. Couldn't I factor the negative 1 out and just write it like that, and then it would look like x squared plus 4x plus 3? They might write it either way. I don't know how they're going to write it, but either way it's the same thing. You could represent it either way. A lot of people don't like looking at that many negatives, so they just want to take it out front. But that's what you could do there.